Hello students, welcome to StudiLive. In this lecture, we will talk about solution. Yes students, solution is the second chapter from the chemistry text. So before starting with the solution, I want you to go to the offers, that is courses that is actually made for you, so that you find your studies very interesting and easy. Okay, so please go through them once. Okay, so now before starting the solution chapter, it is very much important for us to revise what exactly solution is all about. Yes or no? But obvious, on your screen you can see this part. Solution is made by dissolving solute in the what? In the solvent. So let's see over here. Solute is added to the solvent. Solute is getting dissolved to form the solution. So can we say that if I'm talking about solution, it is made up of what? It is made up of solute and solvent. Am I right? Yes or no? But the catch, the important part that we need to understand over here is nothing but solution. Solution is what? Solution, if someone asks you for 1 mark definition, then you need to say solution is nothing but homogeneous mixture. Homogeneous mixture of two or more pure components. What is homogeneous mixture? That they all combine together and present in a one single media. Am I right? But obviously in this part, you can also say solute is present in the less amount as compared to the solvent, and solvent is present in the greater amount or more amount as compared to the solute. Am I right? Okay. So now, I'm hoping you understood this part very well, that what is solution, how it has been made. Over here, we are going to talk about the binary solution that is made up of two components mainly. And our topic of discussion now, what type of solute and solvent we can take to form the different type of solution. So we are actually precisely saying we are doing the classification of solution, and based on the different type of solute solvent that we are taking, there are 9 types of solution we can say. So this 9 type is been classified based on the states of matter. The normal at normal temperature pressure, 3 states of matter is present around us, and we have done the permutation combination to them, and we have got 9 type of solution from them. Okay. Student, I want complete participation of yours to tell me the answer for this. Okay. So we have solute, we have solvent over here, and we are going to do the examples of that solute and solvent. Am I right, student? Now, so I need your help. Just do the permutation combination part. Solute, let's say we have solid. Okay, we have solid over here, and again we are taking solid over here. Okay, then we have liquid. Again, liquid, I'm writing in short, liquid. Then we have gas, gas, and gas. As I said, we are doing permutation combination, that's it. Okay. Similarly, solvent, let's do the permutation combination. We have solid, we have liquid, and we have the gas. I want you to think and tell me the answer of this all. Okay, so we can say if I have solid and solid. So the catch over here, you need to think about for the making of homogeneous mixture. That is the only basic thing you need to understand. Wait, otherwise it's very easy. Homogeneous mixture. So solid forms a solid, that is homogeneous mixture. Can I say simply the example is alloy? Yes or no? For example, brass, bronze, these are the example of alloys, which is solid in solid. Am I right, student? Then I want you to think solid in liquid, solute in solvent. So solid in liquid. So can I say it is nothing but benzoic acid in benzene, or a day-to-day example, which is nothing but sugar in water. Am I right? Solid in gas. So simple, camphor, in air, or simply say iodine in air. Then we have liquid in solids, so small amount of liquid present in the larger amount of solid. Can I say it is mercury forming an alloy with the metal? So can I say it is nothing but amalgam? Amalgam is what? Amalgam is made up of mercury with the other metals. Whatever you take, you can take silver also. Okay. Then we have liquid in liquid. We can take gasoline in as an example, or simple famous example. That is nothing but ethanol in water. Then we have liquid in gas. So small amount of liquid present in larger amount of gas. Can I say which is nothing but, very easy example I'm taking, water vapors in air. Then we have gas in a solid. Let's take hydrogen in palladium. Yes or no, students? So we have hydrogen that we have taken, and we have taken what? Yes, we have taken hydrogen in palladium over there. Am I right? Then we have gas in a liquid. So what can be the probable answer for this? If we have gas dissolved in liquid, the famous, during the summer we used to, we like to drink carbonated drinks. Yes or no? So we say CO2 in water. Am I right? Then we have gas in gas, that is mixture of the gas, homogeneous mixture, that is nothing but the air. Okay, air around us is best example of gas and gas. So the basic 9 type of classification we can say simply for the solution. Am I right, student? Okay, so let's go again to the example that we had discussed already. That is nothing but solution. Okay, but obvious, we had discussed over here, solution is made up of solute and solvent. Yes or no? So now the basic question arises over here, how much amount of solute is dissolved in the solvent to form the solution? So before that, let's try to understand this part, the basic example, student. Okay, what we are doing, we are adding the solute in the given amount of solvent so that it gets dissolved in it to form the solution. Yes or no? And over here, during this process, the solute that whatever, see over here, the solute that whatever we have taken is getting dissolved. Am I right? Solute that whatever we have taken, it is getting dissolved. We are adding the solute, and what is going to happen at particular time is that one time it is going to reach where there is no more solute is going to get dissolved in the given amount of solution. Yes or no? There's a maximum limit of that. And at that point, we are going to name it. We are going to name it as the saturated solution. Yes, saturated solution. So, if someone asks you what is exactly about saturated solution, so it is describe a solution in which it just describes the solution. Let me write that part for you again. Describe the solution in which maximum amount of solute dissolved in the given amount of solution. Yes or no? So maximum amount is there. No more solute is going to dissolve in the given amount of solution if we keep on adding them. So you may have the question how this is actually happening. There is two processes that is exactly happening. First is nothing but dissolving. So we can say dissolution. Yes or no? Let me use another color ink for you. That is nothing but dissolution process, which is actually happening when we are adding solute in the given amount of solute in the given solvent to form the solution. But what is happening, student? After certain amount of time, there is no capacity of solvent. There is no capacity of solvent to dissolve more amount of solute. So there is reverse reaction that is going to take place, and we name it as the crystallization. Yes, there's a crystallization that is going to happen, and there's an equilibrium it is going to reach, and this equilibrium only we mentioned for the saturated solution. So at this point, maximum amount of solute is dissolved in the given amount of solution, because there's an equilibrium between what? Dissolution and crystallization process that had taken place. Yes or no? But always if they ask you about the unsaturated part, you say less than the maximum amount of solute dissolved in the given solution. Supersaturated, it had exceeded the maximum limit. Okay, it had more amount of solute present in them as compared to the maximum limit. Yes, I'm hoping you understood this part about the saturated, unsaturated, and supersaturated solution. But obvious, many students, are still confused between what? We are continuously using one term that is getting soluble, that is solubility, and the another term which is nothing but the concentration. Okay, solubility denoted by S, concentration is, we can say, solubility. Okay, let me write this part again for you. S, yes or no, student? So now, basic part over here, what is the difference between the two? Basic difference we can say, solubility is nothing but the maximum amount of solute dissolved in given amount of solvent, or we can say precisely where it is getting dissolved in solvent to form the solution. Okay, the given amount of solvent at equilibrium, what else they are forming? The equilibrium. So at equilibrium position, can I say that is saturated solution? That is, to form saturated solution at specific temperature. Yes, student, this temperature plays a very, very, very important role. How? We will study that part also. But before that, it's very much important for you to keep this in mind. What is solubility? Maximum amount, the highest amount that can be dissolved in the given amount of solution. Yes. So now, if I'm talking about concentration, concentration is something like at the particular whatever time which is there, what we are saying is how much amount of solute is present. It could be maximum, it could be less than that, or it could be any amount. Okay, so solubility, maximum amount; concentration, any amount of solute dissolved in the given solution. Am I right? Okay, it could be maximum also, it could be any other value. So this is a basic difference of solubility and concentration that you need to know. Solubility, we can say amount of solute dissolved in a given amount of solution. So given amount of solvent precisely. So what we can say about it is that solubility symbolizes as S, which is nothing but moles, the amount that is getting dissolved per liter, or you can say per dm. Okay, this is the basic unit for solubility. I'm hoping you understood the basic part over here. In the basic part, we have discussed what a solution is all about, how it has been made. Okay, 9 types of solution, and very important term, that is saturated solution. Apart from that, we had also discussed unsaturated and supersaturated. I'm hoping you understood this basic part very well. Now, let's go ahead and try to understand the another important concept here. And the another important concept tells us that what if I have different type of solute, I'm dissolving it in a different type of solvent, is that solubility is going to be same for all the cases, or there may be some slight changes that is going to be there. Okay, so yes, you're absolutely right. We are discussing the factors affecting solubility. Yes, this is a very, 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 very important part. So what are the factors that do affect the solubility? Let's try to understand them one by one. Okay. So first and important part is, about the nature of, but obviously it is made up of solute and solvent. So its nature of solute and solvent. What is there over here that we need to understand is that we had already studied this part in our lower grade, that is like dissolves like. Okay, so what is that? This golden words is telling us is that if we are having any polar compound, okay, it is going to get dissolved easily in the polar compound. Okay, let's take a simple example over here. If I'm dissolving NaCl in water, NaCl has charges. Okay, it is made up of cation and anion. Water is a polar compound. What is happening? That NaCl, that is ion-ion interaction, which is there, and but always in case of H2O, there is hydrogen bonding which is present over here. They both combine to form what? Ion dipole interaction. So simply we can say, if I'm saying like dissolves like, interaction between solute-solute, solvent-solvent and solute-solvent, all the interactions are almost equal in magnitude. Okay, so but obviously because of that, they get dissolved in each other very easily. Similar cases for non-polar is getting dissolved in non-polar stuff easily. Okay, this is a golden word, we can say, nature of solute and solvent. Polar in polar, non-polar in non-polar very easily. But obvious, there is some exception to this also, which is there. For example, if I'm talking about sugar, which is a non-polar, and it is getting dissolved in water. But obvious, in our day-to-day example, we know this part very well. Sugar gets dissolved in water. Now the question arises over here. I have one question for you. Just listen this part very carefully. What is the reason that sugar gets dissolved in water? Why I'm asking you? Because sugar is non-polar and water is a polar. Yes, you're absolutely right. If your answer is sugar is going to form hydrogen bonding with water. Yes, so we can say simply because of the interaction with hydrogen bonding, sugar dissolves in water. Don't you think it's very easy? Yes, so the factors affecting solubility. First factor that we had discussed is nature. Yes, two more factors that we are going to discuss one by one. So second factor we're going to discuss is about the temperature. Yes, student. And the another factor that we are going to discuss is about the pressure. That is our topic of discussion for today's lecture. Am I right, student? But obvious this case, in this case, we are also going to discuss mainly what that is solid in liquid, gas in liquid. That is what effect of temperature and pressure is going to be there on its solubility. Okay, but obvious for that, let's take help of what? The table or the graph you can see on your screen. So I want you to give the heading effect of temperature. Precisely the topic that I'm covering right now, effect of temperature on solubility. But obvious, but solubility of what? Solubility of solid in liquid. Yes, this is the main concern over here. Now, if I have different type of solids that all the properties are different, they are going to behave differently. Yes, student? So if they are going to behave differently with different temperature, so let's try to understand this complex phenomenon with the help of graph. So on the x-axis, you will see there is a temperature. On the y-axis, you will see the solubility. So for example, if I talk about NaCl and KCl, there is very slight difference or very slight effect, okay, effect of change in temperature on its solubility, which is that, which is almost similar, we can say, okay. But if I talk about KNO3, if I'm increasing the temperature, solubility is increasing, okay. Similar things is happening with NaNO3 and NaBr. So we can say in most of the cases, not all, if I am increasing the temperature increases, solubility also increases. Okay, some of the cases like NaCl KCl, no major changes there. But always there are few example is also there, very few example is also there, where temperature increases and solubility decreases. Okay, but always there are exception cases. Some of them shows, but right now most of the cases you can go through this. No need to mug up this graph, just small explanation we can say. The first and important effect of temperature on solubility of solid in liquid. What we are going to study in the next part is effect of temperature on solubility, on solubility of gas in liquid. I want answer from you. Have you ever tried to boil water? Definitely, we must have. Okay, so simple example you can see on your screen also, where we have one liquid, we are applying the temperature and it is getting boiled. Okay, what is exactly happening is over here. Can you see over here from the image that is bubbles? Okay, our gas particles are getting escape from the liquid. Yes, so this is a liquid part. Okay, there is a vapors of it, or we can see bubbles, which gas is getting escape out. Okay, we are applying the heat, applying the temperature, increasing the temperature. So what we can say, if I'm talking about the temperature for the gas, can we say simple from our day-to-day life, temperature is increasing, kinetic energy is going to increase, they are going to escape out, intermolecular interaction will become less, but obvious temperature increases, solubility of gas in liquid, it is going to decrease. As I said, for solid it's different, but gas is very simple, inverse proportion is there. Okay, temperature and solubility for gas and liquid, they are inversely proportional to each other. I'm hoping you understood this basic part. Very. Now let's talk about the next important factor. Temperature we had discussed already. Let's talk about the next important part, which is nothing but effect of pressure on solubility. On solubility of what, student? Let's try to understand that part also. So if I'm talking about solubility, if I'm talking about over here, but obvious for the solid in liquid, or we can say solid and precisely pure liquid as a solute, we can say there is no effect of pressure. Yes or no? So solid and pure liquid has no effect of pressure on its solubility. Okay, but precisely if I'm talking about the gas, there is a major space present between the gas particles. So if I'm applying the pressure, drastic change is going to happen. What is that? Let's try to understand from the image. There is image number A and image number B that we can see. What we are doing, we have pressure P1, we have pressure P2 over here. Yes or no? We have pressure P1 and we have pressure P2 over here. But always we are increasing the pressure. So what is happening while increasing the pressure? If you can see from the diagram, you can see from the diagram what is exactly happening. The gas particles are colliding, they are coming together because there is no available space is there. So they have to combine, they have to get dissolved in the given liquid. So can I say for the gas, if I increase the pressure, solubility is also going to increase. But obvious, this is the famous law. That is very much useful in our day-to-day life. For example, definitely say for the carbohydrate, definitely say for the carbonated drinks that we crave during the summer days. Yes or no? So we can say CO2 is a gas, and that is with the pressure it has been added, it has been dissolved into the liquid. Yes or no? But obvious, if you can see there is a pressure over here. As soon as we release the pressure, what is going to happen, student? CO2 bubbles out. Yes or no? So what we can say over here, pressure as the direct relationship for the solubility. Precisely what? Solubility of gas. Only because solid and liquid is no effect. Okay. So pressure increases, solubility of gas in the liquid also increases. This law was given by Henry, so we name it as the Henry's law. Okay, so what it is saying, the solubility of gas in liquid is directly proportional to the pressure of the gas over the solution. Yes, to remove the proportionality sign, what we are going to say, let's say pressure, we are naming it as the P, solubility which is S. Okay, so solubility directly proportional to pressure and vice versa. Remove the proportionality sign, we have proportionality constant, which is KH. K is a proportionality constant and H, that is Henry had given us, proposed this law to us. Is S equals KHP. What is KH? We can say it is nothing but proportionality constant. Or we can say precisely Henry's constant. Okay, student? So the major question that can be asked in your exam, that is, tell us the unit for KH. What will you say? Solubility unit we had already discussed, which is nothing but moles per liter. Okay, so which is nothing but moles per liter. Pressure we can say bar. So what is the KH unit? Can I say KH unit is nothing but moles per liter per bar. This is very, 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 very important part. Okay, so what we had discussed till here is we had tried to understand effect of pressure on solubility, but our solid and liquid no major effect of pressure, but gas definitely is directly proportional, and this law was proposed by Henry that we use in our day-to-day life very much. Okay, we use this law very much in our day-to-day life. But obvious, there are few exceptions to the Henry's law that you need to understand. What is the exception to the Henry's law is that suppose if I'm dissolving ammonia in water, what is going to happen is that ammonia, it is going to react with water. Okay, so but as it is getting reacted with water, it is going to show more solubility than we had assumed. Okay, so we can say this is the limitation. Okay, so for the Henry's law, we need to have non-reactive gases only. Okay, so what if we have the reactive gases? Then it is going to get dissolved, it is going to get reactive, it is going to get react and going to dissolve more than the expected. Yes or no? So more solubility is there as they react with each other. Okay, so the thing that you need to understand, note for the Henry's law, what is that? That we should have non-reactive gas. And what if we have the reactive gas? Then but our solubility differs from the expected observation. Yes or no? Okay. Now, so this was the basic of the Henry's law. Very important. The unit, the formula, okay, the exception part. Also, I have one question for you, which I want you to solve. I'm going to give you as the homework. Question says that oxygen is there. Yes or no? Question says that we all have oxygen in our blood. Okay, so oxygen. Okay, we can say oxygen in blood. Okay, so if I talk about oxygen in blood, if say blood is major constituent is water. Okay, oxygen very slightly dissolve in water. So what is the major reason over here that in our body maximum amount of oxygen is there? Can you guess the answer? Can you guess the answer for this? Okay, if your answer is hemoglobin, then you are absolutely right. Your answer is hemoglobin. Yes, but obvious oxygen very less gets dissolved in water, but because of the hemoglobin, but obvious because of the hemoglobin, it dissolves in water. Yes, the answer is hemoglobin. Very interesting fact to know. So let's go ahead. Let's go ahead. Uh, Henry's law, as I said, Henry's law is very important. 1 mark or maximum 2 mark question that can be asked from the Henry's law. The thing that we need to understand only is about the unit conversion. Okay, so the question is in front of you. I want you to solve. Okay, give it a try. What question is saying? Solubility of nitrogen. Solubility is the particular temperature and 1 bar pressure. So P is very much important. Is 1 bar is this much. So 6.85 into 10 raised to minus 4 moles per liter. First, they have told us to find Henry's law constant. This Ks, there is Kh, Henry's law constant. What is the formula? What is the formula? S is equals to KHT. So we can say that if I want to find out KH, which is nothing but S upon T. So what answer that we are going to get after substituting all the values? We can say we have got 6.85 into 10 raised to minus 4. Don't forget to mention the unit. It's very much important. It is nothing but moles per liter per bar. Am I right? So we have got our first answer. That is Henry's law constant. Second is molarity of nitrogen gas dissolved in water under the atmospheric pressure conditions when partial pressure of nitrogen in atmospheric is 0.75 bar. Okay, it's a little bit trickier one. So what we can say over here is this is the pressure they have given to us for the B part. The pressure is nothing but 0.75 bar. The same condition is given, so we can say we have KH is equals to 6.85 into 10 raised to minus 4. Units are important, as I said, moles per liter per bar. Am I right? Yes. Okay. They have told us to find the molarity. What is molarity? Can I say it's a concentration unit only at particular whatever is there? What is the amount of solute that is present in the given amount of solvent to form the solution? So can I say for this condition, they are actually trying to tell us about indirect indication, not direct, but indirect indication they are given to us is about the solubility. They are asking that how much amount of solute is there in the given amount of solvent. Yes or no? Means we are trying to find, we are finding the solubility. But otherwise we know the formula already we have written over here. Okay, just let's substitute the value to get the answer over here. Okay, so what we can say that solubility over here S, it is going to be 6.85 into 10 raised to minus 4 and 0.75. Important part is what? Its unit. The unit would be what? Moles per liter. Bar it is going to get cancelled. Yes or no, students? So this is the homework part. I'm hoping you are going to solve this part and tell me the answer for this. Okay. So this was the first part of the solution chapter. I'm hoping you understood this part very well. We'll meet in our next class with the Raoult's law and the qualitative property. Okay. Till then, thank you for watching StudiLive.